All right, today we are going to go over Accentuate the Negative Investigation 2.2, which is extending subtraction to rational numbers. A couple of things I want to cover before we move on to today's lesson is that when we went over stuff in Investigation 2.1, we talked about the commutative property and how that is true for the addition of all rational numbers. And we also found that the sum of an integer and its opposite is equal to 0. So 50 and negative 50 would equal 0 when I add them, and negative 17 plus positive 17 would also equal 0. The numbers like 50 and negative 50 are called additive inverses, and you have heard that term a couple of times in class lately. But that just means that when you add them together, you would get a 0. We also refer to 0 as the additive identity for rational numbers, which means that if we added 0 to a rational number, it doesn't change the value of that rational number, which leads us down here to these two examples where negative 7 plus 0 is still negative 7, and a half plus 0 equals a half. These additive identities we use a lot when we get into the solution of equations and expressions, and I've shown you how to use those with inequalities. So now that we're going to do that, let's go look at some subtraction problems and go a couple more pages. I got a subtraction problem in here. There's a lot of information in your book on pages 33, 34, whoops, 33 would be part of 2.1. So 34, 35, 36, it kind of walks us through what I'm going to be going over very briefly and some other strategies. But let's take a look at some subtraction problems. So the first problem I have here is simply 12 minus, or positive 12 minus a positive 4. Well, this is simple. 12 minus 4 is equal to 8. It's been 8 since we left. The difference here is if I went on a number line and I started at 12 and I subtracted, or I moved to the left 4 places, 10 and 8. So I start here and I go to the left 4 places. I would wind up at 8. So this would be the subtraction of 4. Now that my 4 doesn't look like a 4. So that would be minus 4. All right. Now, so that's pretty basic. Now what we have here is positive 12 minus a positive 12. So again, on the number line, if we start at 12 and 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, negative 1. So this would be a negative 1, 0, 2, 4, 6, 8, 10. Okay, and all these are positive. If I start here and I would subtract a positive number, I'm going to move backwards 12 places, or to the left 12 places. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I end up at 0, so my answer is 0. Which makes sense. If I had $12 and I spent that $12, I now have no money. I like to refer to, when we talk about positive and negative numbers, the integers, I like to use money as an example a lot because we all know how money works. So you'll hear me refer to lots of examples using dollars and cents. All right, so next one we have here. We have a positive 12 minus a negative 12. All right, so this one's going to be a little tricky here. Okay, so I'm going to put a positive 12 here. And then I'm going to put some number lines here. And what I want you to do is I want you to think about how we got to our earlier answers through subtraction. What happened? Well, up here, I subtracted a positive number, which meant I moved to the left on the number line 4 places. Over here, I moved to the left 4 places because both numbers are positive. Well, now I have a positive minus a negative. And so I'm going to start at negative 12, and subtraction means we move to the left but then we have this negative here, and it also means that we should move to the left. So what this really means here, the subtraction of negative 12, think about it. If you owed me $12, you would have a debt or a value of negative 12. How do you get rid of that debt? You get rid of that debt by paying me the $12. So in my mind, I'm adding $12, but in your mind, you are subtracting your negative value, thus making it an addition of a positive number. Okay, subtraction of a negative. So the subtraction means that we would go to the left, but since it's a negative number, negatives make everything the backwards, they're opposite. So we would actually end up going back to the right. And so we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. Okay, I'll have to extend my number line a little bit. Okay, so 12, 14, 16, 18, 20, 22, 24. So a positive 12 minus a negative 12. If I rewrite this as my original problem, positive 12 minus a negative 12, I'm going to get a positive 24. And the reason why is that subtraction of one of our values is the same thing as adding the opposite. And you've heard me say that a couple of times over the past couple of days. All right, last problem for today, and then I want you to try to apply this knowledge to question A. So you're going to be doing problem A from page 37 in your book before coming to class tomorrow. All right, so let's take a look at this one real quick. I'm going to draw my number line in blue just to keep it equal here. We have a negative 12 minus a positive 12. So again, I'm going to put my negative 12 in the middle, and I'm going to make my number line go this way a few places, and then I'm going to make it go this way to our left some more. We'll keep going, keep going, keep going. Okay, so 12, negative 14, trying to write small with a big pen, negative 16, negative 18, negative 20, negative 22, negative 22. And that makes this one over here negative 24. And I'm sorry that these are not very decent letters, but it's kind of hard to write tiny with this smartboard. All right, so that's a little better. All right, so we start here, negative 12. And over here on this positive thing, I said that subtracting a negative is like adding the opposite. Okay, do you think that works with positive numbers? That if I'm subtracting a positive, that would be like adding a negative? Well, let's think about this for a second. If you owe me $12, or let's change this up. Let's change it up and say that I owe you $12. Okay, so I have a debt to you, a negative value I have of $12. Well, now I have gone to the store and I need to borrow another $12. I'm going to subtract $12 more from my worth, my value that I have, which would be the subtraction of that positive number. Okay, which means we could show it like this. So I owe 12 and I'm going to borrow another 12, or we could rewrite it as saying that I'm going to subtract 12, okay, so minus a positive 12. Okay, we're going to change this up. I'm going to get a different color here, and I'm going to change this sign to addition, and then I'm going to make this a negative. So negative 12 minus a positive 12 is the same thing as negative 12 plus a negative 12, which means that if we are going to the left, remember subtraction, if I look over here on the red, I'll do this part in red. For this number sentence, when we subtract a positive, we move to the left. Subtract a positive up here, we went to the left. Up here, we subtracted a negative, which meant we actually moved to the right. So right here, I'm subtracting a net positive. I'm going to move to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Whoops, I skipped one. 10, 11, 12. So we wind up at negative 24. So that would equal a negative 24. Sorry about that. Let me fix that real quick. So negative 24 Okay, and I'm going to do the same thing, and this time I'm going to use green to show that the negative 12 plus a negative 12 would be the same thing. Now, if you remember from our addition conversation, anytime we have numbers with the opposite signs, it's just like normal, regular positive number addition. We just would have to include the sign for our number. So a negative plus a negative equals a larger negative number, or I guess technically a smaller negative number. So we're going to start here again, and we are going to add another negative 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and this is really crummy. Anyway, so it's the same thing, and this is basically just proving, again, that if we are subtracting a sign from another sign, we can actually add in the opposite sign. And that goes back to earlier in the video when I was talking about additive inverses. Okay, so I'm going to give one more problem. I know the video is a little bit long, but I want to make sure that we understand this additive inverse thing. I'm going to say that we have a positive 24 minus a positive, let's make it simple, 12. Okay, and then I am going to show you in red how a positive 24 plus a negative 12 also will give me the same answer. Again, subtraction of a positive should equal the same thing as the addition of a negative. All right, so we're going to draw out this number line. Okay, so let's take a look at the first one, the positive 24 minus a negative 12. So that means that we would start over here at positive 24. And we are subtracting a negative. So when I subtract a negative, that means that I am, subtracting a positive. That means I am moving to the left a positive value. So these are positive numbers. We're moving to the left. Subtracting means our answer will get smaller. Positive minus a positive should equal a smaller value. So our number is going to move to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times to our stopping point here. So positive 24 plus a positive or minus a positive 12 will equal a positive 12. Now, in red, I'm going to show you that a positive 24 plus a negative 12 is also going to equal a positive 12. Okay? So, in red, start at positive 24. We're adding in a negative value. Now, negative values are opposite. If we are going negative, we are actually moving on the number line to the left. Okay? Smaller values. So we're going to add in 11 places to the left. That's what this means. Add in 11 places to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we wind up at the same spot, positive 12, thus proving that a subtraction of a positive is the same thing as the addition of a negative. All right, I know that video is a little bit longer than normal. Take a few minutes if you need to, kind of review. Let's go back up and I'll leave you with, before you come to class tomorrow, you do need to come with problem A from page 37.